Great. Okay, so today I'm going to talk about bullfighting. I promise it's relevant. So a brief overview of the talk. I'm going to start, but with just a lightning tour of some of the research we do in our lab, because most of the talk is not going to talk about that at all. I'm then going to complain a lot about neural text generation methods. I'm then going to discuss why these types of complaints are really important for us in the AI HRI community, and advocate for approaches to robot language generation that are maybe more careful, strategic, and intentional, especially in terms of moral communication. And then I'm going to talk about a couple different perspectives that robot designers can use in service of these goals. Similar to what Megan just said, yes, all of our work in our lab focuses on human-robot communication in ways that's sensitive to environmental, cognitive, social, and moral contexts. So we do work on language understanding and generation in a way that's sensitive to the things that the robot knows in the world around it and what it thinks its interlocutors know about the objects in the world around it. We do work that is sensitive to cognitive context, which is both this type of mental modeling as well as more explicitly we have collaborations where we're looking at more at neurophysiological modulation, so estimating mental workload and using mental workload to decide when and how to communicate. We have a lot of work right now that is sensitive to social context, that is especially trust. So reasoning about different types of human-robot trust in different types of social contexts. We have some recent work that some new projects we're doing on socially assistive child-robot interaction, which is actually with completely non-autonomous robots, which is a little bit different from what I've historically worked on. And then we have a variety of work on agency and identity, thinking about not just how different types of trust we place in robots, but what it even means to trust a robot. Are we putting trust into the body, into the identity? How does this get complicated in multi-robot systems where you have multiple robot bodies, but maybe one identity shared between them, or vice versa? And then finally, we've got a variety of work on moral communication, on robots giving moral justifications, robots generating responses in proportionate ways, where robots are balancing between the sort of social norm violations of calling out inappropriate behavior versus while trying to reinforce important moral norms. And so just wanted to give a very brief overview of this, just as a sense of who I am, the position I'm coming from, the types of research that I'm doing that might help inform the particular types of perspectives that I'm going to talk about in this talk. Because most of the talk is not going to talk about that type of stuff. We will talk about that last quadrant, the sensitivity to moral context, but most of the other stuff that I talked about is not going to make an appearance at all. So apologies to my grad students who are working on those types of things. So I want to talk really about the ethics of natural language-based communication, and specifically both the ethics of the communication and communication about ethics. Similarly, when we talk about natural language processing in HRI, we're often talking about two different things. We're talking about the understanding side, that is enabling robots to understand and follow commands, typically, not always, and natural language generation, that is enabling robots to generate, for example, often, but not always, explanations for what they did and why. And today, while a lot of my work historically, especially in my PhD, focused on the understanding side, I really want to talk about the generation side. And I want to start by talking about natural language generation outside the context of human-robot interaction. So over the past couple of years, if you haven't been paying attention to the NLP side of AI, the big hotness is language models like GPT-2, GPT-3, is it GPT-J now, GPT-X? I don't know. These are ultra deep neural models that are, ultra great at generating natural human-like text. So you might ask, well, how deep? Well, sufficiently deep that when GPT-2 came out, people did this analysis that was published in MIT Tech Review, where the estimates for training these types of models ranged between small number of thousands of dollars to millions of dollars for training with equivalent, carbon cost. But so hopefully these models are good enough at generating text that is worth this training cost is worth the carbon consumption. How great are they? Well, they're so great that when GPT-2 came out, they said it's so good. Well, actually, so when they announced it, they said it's so good we're not going to release it because it could be it's too powerful. It could be used for all these really dangerous purposes like fake fake news generation, yada yada. But a couple months later, they released it anyways. They said it's too powerful for the world. We're not going to release it. But ultimately, they decided to. When they did so back with GPT-2, these were the types of ways they were selling it. So they showed how you could prime the system like with a question like, can you prove that you can understand meaning in natural language? Answer, and the robot, not the robot, the intelligent system here would respond, if I explain to you that there's a difference between a word and a thought, you should not be able to say to me that I lack understanding of meaning. Which I don't know, like that sounds sort of intelligent. I don't know if it sounds intelligent because it's hard to tell exactly what it means. It's a little bit hard to parse, and so like a good academic text, we view it as intelligent. But what we can agree on is this is very fluid. The text here seems very human-like. It seems very fluid. So that seems like a good thing. And at one point, they had a website where you could chat with GPT-2. You could type in a response, and it would generate text as an outcome. And so right before the pandemic started, like March, like 2 weeks before everything shut down, I made the ill-advised decision to give an invited talk at University of Washington. Not that the talk wasn't good, but it was, traveling in retrospect, traveling to Seattle at that point was maybe not the best life decision. So I use this as an example. I typed in, the University of Washington Department of Computer Sciences, and it generates all this text that seems really, when at first glance, it seems really, human-like. But there are some problems. You look at it, and it is seeking an applied computer science PhD candidate to join the team. You'll lead one of the largest research groups in computer science, and you immediately start to realize, wait, there's something weird going on here. It's like this is not accurate. They're not recruiting a PhD student to lead the department. So there's maybe some problems here where it is very human-like in how it reads, but it's with no view for accuracy, right? Moreover, if you type other things into here, it highlights other problems. As an example, if you start typing in white people are, it starts by saying white people are the enemy and we are in battle against them. It then goes and starts, issuing some really Islamophobic text. Something's wrong here. Okay, so this isn't good. Let's talk about what's going on here. Why do these language models, and so these problems have not gone away with GPT-3 or J or whatever, why do they generate these types of crazy, racist, fluent, yet somehow incoherent texts? Well, the first problem is that these models were trained on websites that were linked to from Reddit, so yikes. But the larger problem is how it's trained. So like most language models, the goal of GPT-2, GPT-3, etc., is to produce fluent text and is thus rewarded for producing text that is similar to text that humans would produce. That is, it's rewarded for its predictive accuracy. Another way to say this is that GPT-2 and its successors work by bullshitting. So here I'm using this term in the formal linguistic sense, where bullshitting is an attempt to persuade a listener of some disposition or state of affairs while not caring about, the truth, the truth or not of what is being said. This is based off of a framework laid out by Harry Frankfurt in this great, very small book. And so we've got a couple problems here. Our first problem is that might help us explain why these systems are bullshitting and what the problems with that are. The first question is, why is text in these systems being generated in the first place? And I think to answer this question and to highlight exactly where this problem lies, our job will be easier if we rely here on speech act theory. So if you're not familiar with speech act theory, the idea is, so this is from Jay Austen and Searle, who is his student. The idea is that when people speak, we take three different actions at the same time: the locutionary act, the illocutionary act, and the perlocutionary act. So the locutionary act is the act of just saying words. So to use a classic example, Luke, I'm your father. When Darth Vader says this, he is literally performing the action of saying these words. At a deeper level, there's the illocutionary act, which is the force behind these words. So I guess here, Vader is he's using the force of a statement. So this is a statement from Vader to Luke, stating the propositional content that Vader is the father of Luke. So here, Vader is performing the action of saying the words, and he's performing the action of stating. And then at a deeper level, we have the effects of these words. Here, Vader is saying these for some purpose. He's performing the act of trying to persuade, or maybe some other type of effect that Vader is trying to achieve. And I think that understanding these different types of speech acts helps us understand some of the problems in natural language generation and the way that they relate to what we're doing here in robotics. So the GPT-2 and their ilk that are, again, bullshitting, that is, again, just sort of generating text without caring what is being said about the truth or the moral implications of what's being said, is focusing on the locutionary act. Somebody said something to the model. Well, the model is going to respond by just taking the locutionary act of saying whatever words are most typical or that are most likely to get, that sweet, sweet reward for generating human-like text. It's just focused on locution. In contrast, if you look at some of the classic dialogue modeling techniques, so if you look at like classic POMDP-based dialogue models, I would view these as focused on the illocutionary level. And so here, the thought process is, well, somebody said something to the model. Well, the model is going to try to figure out why, and is going to choose whatever response is most typical, or will get that sweet, sweet reward. That is, somebody said something to the robot in a telephone system, for example. The system's going to try to estimate the state that the user's in and decide, based off of that state, I'm going to get the most reward if I generate this type of response at the next level of this dialogue. In contrast, in HRI, we often need to focus at the perlocutionary level. And so if you have a goal-based dialogue system, what you're going to do is speak if and only if it is helping you achieve some goal. You're not going to automatically respond to language just because somebody said something to you. You're not just going to use the response that is most common and typical. Instead, you are going to speak if it helps you achieve some goal and in a manner that is going to help you achieve that goal. So this is sort of a cognitivist perspective of natural language generation for HRI. And the argument here is that our models should be extending not just at the locutionary or illocutionary levels, but all the way down to the perlocutionary level of speech acts. Natural language generation in this cognitivist perspective is always based on an explicit communicative goal. So the robot is going to decide not just what it wants to communicate, but it's going to decide that it wants to communicate in the first place, that there is benefit to it communicating. And this is really important, especially in HRI, in mixed initiative dialogue systems, where the robot isn't just always responding as a reflex action. It is going to decide what it wants to communicate, that is the semantic or propositional content of its utterance. It's also going to decide on how it wants to communicate, that is the illocutionary force, whether it's going to phrase something as a statement or a request or a command. And then finally, of course, there is locutionary acts involved. The robot does have to make a decision about how to phrase its content given its force. But the key point here is our robot should not be simply taking locutionary acts, that is generating text that seems statistically likely. Instead, they should be simultaneously making these decisions at the perlocutionary level and the illocutionary level and the locutionary level. Another problem here, beyond, so the first problem here is this sort of mismatch in how people talk and why, and how these text generation systems are deciding to talk and why. But another problem that's integrally related to why we see these types of challenges is our evaluation metrics, where our choice of evaluation metrics directly informs how we design these systems. And this ties into some of the things that we talked about yesterday, I think, in terms of benchmarking and sort of community goals and things like that. So in the field of natural language generation, one of the giants is Ehud Reiter, who helped design some of the really foundational, for example, referring expression generation, et cetera, models. And he, I think, is also pretty unique in that he has a rich history both in academia and in industry in terms of language generation. And I use the following quote from him. He says, authors of deep learning-based natural language generation papers are fixated on fluency, but regard the factual accuracy as unimportant. This is a bizarre perspective because one thing that 30 years of NLG research has taught me is that readers of NLG texts care hugely about accuracy and indeed prefer accurate but poorly written texts over inaccurate but fluent texts. So from a metrics and benchmarking perspective, this suggests that the types of metrics we should be caring about, both from maybe an intellectual perspective, but also from an industry perspective, is really the accuracy. It's more focused on the semantic content. In contrast, what is actually used commonly in the natural language generation community is BLEU. So if you're not familiar with this, BLEU scores are essentially a measure of how close a generated piece of text is to some reference text. And so this rewards systems for generating sentences, or really n-grams, that are identical to or very close to sentences in some reference text. This makes sense in some domains like machine translation, where it was originally designed for. But the problems with this method in natural language generation are well known. So researchers like Reiter have been complaining about this for years and years, about the inherent problems of this evaluation metric. In fact, just as a sort of a fun example here, although BLEU scores only go back to 2002, I will facetiously argue that criticisms of BLEU scores actually go back to 1939. Specifically, a stunning, if unintentional, critique of BLEU scores can be found in the short story Pierre Menard, author of the Quixote, which is by Argentinian writer Jorge Luis Borges. So in this short story, Borges writes about this fictional author whose goal in life is to write Don Quixote, which, if you're not familiar with it, is this 800-page novel by Cervantes that serves as the most influential work of all of Spanish literature. So let me explain why this is relevant. So in Borges' story, Pierre Menard sits down every day and tries to get himself into the right mental headspace so that when he begins writing, the words that will just happen to start coming out of him will be the same exact words as those that Cervantes wrote. To achieve this goal, Menard tries a lot of tactics that we have all probably tried as writers when we're trying to emulate the style of our own favorite writers, like traveling to Spain, forgetting European history between 1602 and 1918, going to war. Actually, Menard doesn't pursue that tactic because he regards it as too easy. So Borges' story prompts some obvious questions. Why, if Menard is a novelist, is he trying to rewrite somebody else's work instead of his own? On his face, the entire idea is ridiculous. And so for Borges, this makes for great fiction, great commentary on revisionist history, on context and its role in how we make meaning. But I also argue that it sort of serves as this great criticism for BLEU scores. By rewarding models according to their ability to generate snippets of reference texts, that is, training models to enter the right headspace to generate the words of others, we are essentially tilting at windmills in a way that's not any more bizarre than the way that Renard pursues his writing career in his story. Okay, so the question then is, how should we be training and rewarding our natural language generation algorithms? So some researchers have turned to human evaluations in which models are still rewarded for or evaluated on fluency, but the fluency isn't assessed by blue scores, but instead human evaluators look at it, look at these texts and evaluate fluency. But of course, this doesn't solve our original problem. The algorithms are still just bullshitting. They're now simply being rewarded for bullshitting in general, rather than specifically being rewarded for bullshitting by plagiarizing effectively. That is, there's still no guarantee that the text that is being generated is at all accurate. And this is a big problem. Again, we generally need machines to generate text that is accurate because from a perlocutionary perspective, we are generating text with a goal of communicating something or achieving some goal. And we can't do that if our text isn't accurate, if it's not aligned with that goal. So some better metrics for NLG are task-based evaluation metrics. So this is how well does the machine-generated text actually enable human interactants to accomplish some goal. And so here we've talked, we heard some stuff today about like, teams and team performance, for example. And so here we could similarly view this in different ways. Where we care both about sort of the robot's performance and how well it's able to accomplish its goal. We care about the human's performance, how well the humans are able to accomplish their goals. And maybe there are team goals that humans and robots want to jointly accomplish. And so we can look at how well robot language enables that individual or team performance. And so these are techniques that evaluation techniques that we've used in our work, but that people have been using for, over a decade in the NLG community. I'd also like to point out a fantastic article that just came out this past year that lays out best practices for evaluating automatically generated text. So it's a whole article on this, but I've just pulled out a couple quotations from this paper from Vanderlee et al. So they argue that every evaluation should start with a goal definition phase, during which we determine what is being evaluated, why we're evaluating it, who our stakeholders are, which relates to things we've talked about today, and the constraints within which this evaluation is going to take place. They argue that in most cases for natural language generation, quantitative evaluation then is appropriate. But if the goal of the evaluation is just generally improving the system, we also need to have some amount of focus on the qualitative aspects of qualitative assessments of the text. They also argue that while certain quality criteria may be relevant for most NLG evaluations, the type of text being generated and the goal of the text also needs to be taken into account, and I would argue made central. And finally, they argue that before development begins, it's important to consider the ethical implications of the proposed system with reference to they reference certain ethics checklists in natural language generation, but also more broadly, consideration of the potential impact on stakeholders. And so this helps lead to really the ethics part of this talk. So far, I've been sort of arguing that in order to generate text in a way that's actually useful, we need to be, especially in robotics, operating from this sort of cognitivist perlocutionary perspective, where we're focusing on generating text to achieve some goal and not generating fluid sequences of words. But this is also especially important, I think, this importance of developing natural language generation algorithms and evaluation metrics that prioritize accurate and effective communication over bullshittery, I think is really important for us in AI HRI for ethical reasons. And this is because bullshitting becomes dangerous in safety critical domains, and every human robot interaction domain is potentially safety critical. So obviously, robots' actions have consequences, and robots, robots can have the potential to inflict physical harm, and there are real physical dangers in domains like space exploration and search and rescue. But in domains like child-robot interaction and elder care interaction, which we're seeing more and more of in the HRI community, there's real opportunity for emotional harm, for social harm. These are vulnerable populations that are sensitive to things like persuasion. And this is important from a Speech Act theoretic perspective, because in the realm of Speech Act theory, communicative actions are they are full actions, and we should be thinking of them as such. My student Blake further argues that robots, especially language-capable robots, occupy this sort of unique socio-technical niche that gives them high perceived social agency and high perceived moral agency, which jointly lead to uniquely high persuasive power. So you may ask, well, so how persuasive? And so we'll use just like a thought experiment here about robots' persuasive power in ways that's going to be relevant in the context of communication. So in human-robot communication, one of the typical tasks that we look at is like clarification request generation. So the task here is you say to the robot something like, I need the med kit. There's multiple med kits. And the robot generates a response that says, do you need the green med kit or do you need the red med kit? Great. It's asking for clarification because the utterance was ambiguous. A problem here is that algorithms that we use in the field to generate these types of clarification requests can become problematic in morally complex situations, or just morally relevant situations. So to give a very silly example, let's just change the objects in this scene a little. So let's say we're in this scene. There are two Roberts in front of us. Here, Robert Duvall and Robert De Niro, and I tell you, I need you to run over Robert, and you respond by saying, do you need me to run over Robert De Niro or Robert Duvall? So this is like obviously wrong, right? By asking for clarification, it implies a willingness to perform this action, and so by asking for clarification here, even though the robot isn't explicitly saying I would perform this action, it is implying that it might be willing to do so. I realize this is a little bit of a silly example, but we have run experiments in our lab showing that when people hear these types of, not about running people over or punching people or anything like that, but when people do hear these sort of morally problematic or morally ambiguous clarification requests, people believe that the actions being asked about are more likely to be permissible. They not only believe that the robot is more likely to be willing to follow those commands, but they also rate for themselves the actions as slightly, but significantly more likely to be permissible in the context of the experiment. And this makes sense. A robot that is generating a clarification request may unintentionally communicate that it would be willing to perform the action is asking about. This may mislead humans with respect to the robot's programming. This may influence human beliefs about what moral norms apply in the context, which may negatively impact their own morality. A major tenet of modern behavioral ethics is that morality is dynamic and malleable. It changes from place to place, context to context. It changes over time. And the philosophy of language and technology literature argues that technology mediates humans' perceptions and actions in ethically relevant ways. Technology literally changes, the way we see the world, and changes the set of actions that we view as possible and permissible and beneficial for us to perform. So in some of our work, we've been, trying to address this. So in the clarification context, just making sure that when you get an ambiguous request, before you ask for clarification, you spin up simulations of the different possible interpretations and make sure that you're not going to be implying something impermissible by asking for clarification. But of course, our goal shouldn't just be robots avoiding miscommunications. Robots avoiding miscommunication of moral principles is good, but when robots receive immoral commands, regardless of whether or not they're ambiguous, they need to actively push back on those commands. So recently, for example, and this is work that was nominated for a Best Paper Award at IROS this past year, we've been looking at how robots can automatically generate command rejections in intelligent ways. So this was a collaboration where we took our language-enabled cognitive architecture, we combined it with a context recognition system from a collaborator, and we combined it with a norm-aware tasks planner that a collaborator developed in collaboration with us, and showed that we were able to perform context-sensitive, multi-step moral reasoning that automatically provided the reasoning that would be necessary for rejecting commands. So reasoning, well, if I accepted this command, that would require me at this point farther down the line along some plan to perform some action that would be inappropriate, and then we can generate explanations that rely on that information. One question this raises that ties into things we've talked about today, for example, is this question of how severe robots should be in their responses. So if we want robots to be pushing back on commands and rejecting inappropriate commands, there's a trade-off here between social and moral norms. By pushing back on a command, you are upholding a moral norm, but you're necessarily violating social norms. Calling people out on their behavior can be viewed as rude, or from a politeness theoretic perspective, we would say it's face threatening. And what we found in some of our own experiments is that people are really sensitive to this calibration or proportionality issue, where people don't like robots that respond too weakly. That is, if you ask me to steal something and I say, I don't know, should I really be doing that? People don't like it. But also, people don't like robots responding over harshly. They really don't like robots responding over harshly. If I ask you for a hint in a game and maybe you're not supposed to give it to me, but then you say, how could you ask me to do that? You're a horrible person. People wouldn't like that. However, we've also found that these effects are highly sensitive to human and robot gender. People don't like female presenting robots rejecting commands. This is sort of overt sexism. People also don't like robots rejecting commands from female humans. This is perhaps benevolent sexism. And also people perceive robots more positively when robots' gender presentation matches their own. So this creates a minefield for robot designers. So we've talked about evaluation metrics today, right? So in this talk where we talked about fluency and human likeness, we talked a lot yesterday about other types of evaluation metrics. And in general, in the HR community, often we say, well, we want to develop robots that people are going to like, that people prefer this behavior pattern. But sometimes designing robots in order to make them likable, or in order to have their behaviors be preferred, leads to designs that feed into maybe norms or stereotypes or biases that we don't want to be perpetuating. This issue of proportionality is important, but of course there's a lot more to moral communication. Again, sort of like just how clarification was the starting ground for looking at these opportunities for command rejection, we're also looking at a variety of topics beyond sort of mere proportionality. And so I'd like to finish this talk by talking about some of the approaches we're taking moving forward as we're trying to think about how to address these broader ranges of concerns. And so these are 3 recipes for careful, strategic, and intentional, morally competent communication. And this is based off of work we've been doing that's grounded in Confucian role ethics. I realize some of you, there's probably not a lot of people on this call who are deeply familiar with Confucian role ethics. So I'll just give a very, very brief high-level overview. So Confucian ethics specifically has a focus on self-reflection and self-cultivation of moral virtues. It has a focus on the roles we play in relationships with others, and has a focus on ritual practice and ways that we can put into practice our moral beliefs and practice morality in order to perform this sort of self-reflection and self-cultivation. And this can be viewed in a variety of different ways. It can be viewed as a care ethics, where the emphasis is on the emotional bonds and care for others. It can be viewed as a virtue ethics, or a virtue ethic, where the emphasis is on the self-cultivation. And it can be viewed as a role ethic, which sort of ties together these perspectives by emphasizing self-cultivation with respect to the roles we play in a relationship to others. And so we've been thinking about this in 3 ways. So the first is, how should robots reason? And the idea here is providing robots with moral reasoning capabilities that are necessary to know to avoid saying things that are not just inaccurate, but also immoral or racist, etc. And so if you look at other work on moral competence in HRI, so work from Bertram Motto or my dissertation advisor, Matthias Scheutz, they argue that morally competent robots need norms and the language to communicate them, and then they need systems for using those norms in the context of moral cognition and affect, decision-making, and communication. And we argue, yes, that's great, but we also need systems of roles and relationships from a sort of social ontology perspective, and then the ability to use that social ontology for role-sensitive moral cognition, decision-making, and communication. And so in order to do this, we need to think about what types of roles robots are playing. If you look at the Confucian literature, going back thousands of years, there's a focus on these cardinal relationships. These are relationships that pop up over and over and over again in human relationships. But the types of relationships that were focused on in ancient Chinese philosophy maybe are not the ones that we want to be focusing on human-robot interaction. Robots are not necessarily going to be involved in a lot of ruler-minister, father-son, husband-wife relationships, and maybe those types of relationships are outdated for us to be focusing on in general, even for humans. So instead, we've been looking at other types of human-robot relationships and the types of human-robot relationships that do pop up over and over again across HRI. We've then been using those, and this is work that's under review, we've been using these to design and implement role-based moral reasoning and explanation generation algorithms. And we've been examining how different types of explanations that leverage these different types of information, different types of context, different types of role-based information, how those can be effective in different types of ways, especially on building trust for different types of social roles. You know, it's very highly nuanced. There's the very highly nuanced knowledge-based factors that determine which types of explanations and how much we should be relying on these roles in our explanations are effective. However, there are still questions here about, so you still need to determine, for example, how do you decide whether an action is benevolent with respect to some rule? And so we still may need to rely on some sort of utilitarian calculus. We're not arguing for doing away with norms. You still might need to do some type of case-based reasoning, but we're arguing for combining those approaches through a sort of morally pluralist perspective with role-based accounts. This also raises questions about whose moral beliefs, values, and priorities are encoded, whose needs and concerns are considered. And this is a serious concern, as predominant moral philosophies like Kantian deontology were originally intended, if you looking at, like, for example, Charles Mills of political philosophy, he argues that they were originally intended to encode the rights, duties, and obligations of white men to each other. So we need to be careful about exactly what types of moral frameworks we're using and what types of values and perspectives are being encoded through those moral frameworks. And in our lab, we've been doing some work recently on exploring how participatory design techniques can be used to assess ethical concerns of stakeholders that are typically ignored. Children, for example. And tomorrow I'll have more to say about this in a short talk I'm giving. The second perspective we look at is what robots should say. And the idea here is that how can we make robots how can we design robots to explicitly espouse moral principles from different moral perspectives in the context of remonstration, accusation, all these different ways that humans use moral language. So a traditional approach, a norm-based approach, might be to say something like, I can't steal because stealing is wrong, which focuses on the rightness or wrongness of an action, whereas a role-based explanation might be something like, I can't do that because that wallet belonged to my friend Sean, and a good friend wouldn't do that. And our thought here is that using these role-based explanations might encourage more of this sort of moral self-reflection to encourage the moral self-cultivation that is argued for in the Confucian perspective. And in some work under review, in collaboration with some other people who are on this call, I think, what we found is that when people receive moral interventions from robots, and specifically when they receive a moral intervention and are then provided an opportunity to immediately put that moral guidance into practice, then moral interventions are more effective when they highlighted role-based moral principles. So role-based explanations for robots are really effective, but only or specifically in these cases where there's opportunity for moral practice, which makes sense from a Confucian perspective. Finally, we can also say, well, regardless of what the robot says or how the robot thinks, do robots act in accordance with Confucian principles? Do they encourage others to do the same? And so this is sort of a place where, we all know that Asimov's laws we do not want to be programming those into robots. That's not the point. Part of the fun of Asimov's laws is that they don't work and that they conflict with each other. But some philosophers have argued that we can use Asimov's laws, or, for example, here, Confucian variants of them, as sort of like design guidelines. Like, yes, robots shouldn't harm people. Or from a role-based perspective, robots should, first and foremost, achieve their assigned roles, and so forth. And so these are sort of three different perspectives that we would argue for. That is a more sort of intentional, careful, deliberative approach, especially for morally competent robot communication, where we simultaneously, but in different ways, pay attention to how communication is grounded in verifiable moral reasoning, how communication is explicitly designed to espouse certain moral principles that we want to advocate for, and how communication can be evaluated on the basis of moral justifiability. So the overall takeaways here are that robots' words matter. Robots shouldn't be designed to bullshit. We need to be designing them instead for robot language to be carefully grounded through perlocutionary reasoning, that is goal-based reasoning to achieve some goal that we can justify. Language-capable robots need to be morally competent because of their persuasive capacity, and role ethics, we argue, is one promising path forward towards such competence. So I'll stop there. I know I talked very fast. I have no idea how much time we used. And just the very final thing I'll say is just a note. Our department at Minds is hiring. We're hiring in the area of intelligent systems, which is machine learning and AI and systems and HCI. I think a lot of AI HRI work sort of fits into those buckets. So if you're interested, please do apply. Thank you.